investigating inverses. Okay? Before we start on this worksheet, I want to know what kind of words you think of when you hear the word inverse. What does that make you think of? So inverse operations. What else? When you hear the word inverse, what do you think of? Opposite? Anybody else think of anything else? Switching? What do you mean by switching? Changing them? What's Okay. Let me try. Okay? First of all, let's make something clear. When we're talking about opposite, examples of opposite numbers are 2 and -2. Or -4 and 4. What does opposite have to deal with? The sign, right? It has to do with the sign of the number, okay? That's kind of what negative is too. It just changes the sign on the number, right? If we multiply it by a negative. These two are more in line to what we need to talk about. Okay? So let's go back to this actual worksheet, investigating inverses. Number 1 says, look at the ordered pairs in each table. What patterns do you observe? What is switched? X and Y are switched. X values and Y values are switched. Okay? So for each table, plot the points in order and connect them with line segments. So if I plot this point and then I plot this point, I'm going to connect those two with the line segment. And then when I plot the third point, I'm going to connect those two with the line segment. Does that make sense? Then I'm going to plot table 2, except when I plot table 2, I'm going to use a different color. Okay? Plot the points in table 1 on your paper, and we'll go from there. Okay, do you have your first function graphed? Yes or no? Out loud? Okay. Can you even see that? Is that a little better? Okay, I'm going to plot the second table. I'm going to plot mine in red. Okay? Any questions so far? Do you have yours done? So how are the two graphs related? What patterns did we observe? So how are they related? X and Y's are switched. What transformation occurs? A translation? That's a good guess. A reflection. Okay. A line of symmetry runs between these two graphs. Trace it with a dotted line. Where is that line of symmetry? The easiest place for me to see it is up here, right? Can you even see that dotted line? Let me use a pen. Like that? Whoops. It would help if I would have graphed it correctly. So ignore that part right there. Do you see that line of symmetry? What's the equation of that line? How do you know that? How do you know that it's y equals x? So the slope is 1. So if we were filling in y equals mx plus b, my slope would be 1, right? So y equals 1x plus, and where does that line cross the y-axis? At the origin, so 0. And if we strip away everything that's not necessary, we cannot write the 1 and we cannot write the 0, and what we end up with is y equals x. Okay, so does that make sense at all? Does it make sense that it reflects over the line y equals x? Well, remember what we did, guys. In this first table, these are x's and these are y's. In the second table, we rewrote the x's where the y is and rewrote the y's where the x is, right? And so at some point y equals x and x equals y. So does it make sense that it's reflecting across the line y equals x? Hopefully, yes. Okay? Next worksheet. This is an activity. Okay? Unfortunately, because of time and space and the time-space continuum, we are not going to be doing number 3 today. So you can cross out number 3. Okay? No, just 3. In this activity, you will continue to explore inverse relations by investigating inverses of linear functions. So we're just talking about lines here. Okay? Choose values for m and b to write a linear equation in slope-intercept form. Do it. I do have some suggestions. I would suggest that between both of these numbers, you don't go any lower than -5 and you don't go any higher than +5. If you do, there's not a whole lot of dots that show up on the graph and it's not always very clear. Okay, so I'd stay close to 0, but please don't make both of these 0. And I kind of prefer if you don't make both of them 1. Okay, what did you choose? 2 and 1? Grant, what did you choose? Hunter, what did you choose? Okay. No, I need that one. I definitely need that one. Who will be brave and volunteer to do the one I ask you to do? Larry? Would you graph y equals -1 plus 2? Please? Thank you. -1 plus 2. Okay? So, I need points into this table from that equation. Gosh, I wish there was an easy way to get a table if we had an equation. Oh, you could get your calculators. What a great idea. Go get them. I would really prefer if you guys were in a habit of grabbing it every day. Grab your calculator every day. Okay, I'm starting again in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, go to, first of all, turn it on. Okay, turn your calculator on and go create a new document. Go home, not literally home, but press the home button. And see on the right hand side it says new document. Create a new document. It's going to ask if you want to save the old one. No, you don't. Okay, say no, you don't want to save the old one. And what kind of document are we opening? A graph. Open a graph. Is the entry line at the bottom where you enter y equals? Okay, if that disappears for any reason, do you know what to press to make it come back? Tab. Very good. Very good. Okay, if yours is there, enter it. Enter this equation you just said. If not, press tab and then enter it. Okay? After you enter your equation, press enter. Did it graph your line for you? Now, let me blow your mind. Press Control T. Yeah. It pulls the table up for you, doesn't it? So you need to fill in values for this table over here. Okay? Please fill in important values. Don't fill in -5, 23, -4, 21. Because you can't graph those points on this graph. Fill in points that are going to show up on this graph, knowing that this graph goes from, I believe, -10. 3, 4, 5, 6, 7, 8, 9. Yeah, -10 to +10. You may have to use your up and down arrows to move around your table to find an appropriate window. Do you have it? So some of you might have more points on your paper than others, and that's okay. Let me see it. Oh, because you put y equals. Yeah, it's already there. When the f of x is there, remember that's kind of the same. So just put 2x plus 1 right there. And when you hit enter, it shows up. Okay? Did everybody have some values down on your table? Please plot those values on your graph. Plot those values on your graph. Okay, once you get it done, you can actually look at your graph, because we have the graph pulled up still, right? And you can compare them to make sure that they're the same, correct? Okay? Everybody have that done? Okay, how are we going to find the reflected line? What do you think? How do we find it on this paper? What did we do? Switch x and y, right? So take all your x values on this table and fill them in on the y column. Take all your y values on this table and fill them on the x column. Once you do that, plot those points on this graph in a different color. Describe the patterns you observe. What pattern do you see in mine? I see an X. That'll work. Does everybody see an X? Hunter, let me see yours. Hunters don't cross at all. So who's right, me or him? Didn't we both do the same thing? If you looked at his table, didn't he take X and Y and switch them? Didn't I take X and Y and switch them? So why did I make sure Hunter had this slope? A slope of 1. Even though they may not cross at this dotted line, it still can be possible. Larry, let me see yours. It's fine. What did you do? I'm trying to figure out what you did. I don't understand why you have 3 lines. You have that and that and that. Anybody else do a -1 as their multiplier? You did? Let me see it. Leave it right here. I didn't ask you what it did. I just said let me see it. So she clearly did not follow directions, right? Because we're supposed to have 2 lines. Mine did. Hunter's did. She only has 1. What? Did she take X and Y and flip them? Look, did she? So what happened? What happens when you flip numbers like this? It's the same point. What happens when you flip 0, 2 and 2, 0? You're going to get the same point. Now it's not, this isn't the same point, but this is the same point as that. This is the same point as that, right? Okay? So this is what I want you to do. Stay right here for a second. This is what I want you to do. I want you to fold your paper like this, right along that dotted line. Okay? Thank you. Oh, right, hold on. See if you can figure out what you did. Okay? Fold your paper right along the dotted line and hold it up in the air. Look at it, hold it up in the air. What do you see? I see 1 line, right? This is that. This is right on top of that, isn't it? Is that the same for this one? Is that right on top of itself? Does yours work? Thank you. So first of all, we'll come back to that in a second, but what patterns did we observe? On mine, my pattern was it makes an X. Okay? So you have 5, 6, 7, and 8 to do for homework. I hope you have a great weekend.